Hello and welcome to Android Developers Backstage. I'm Tor Norby from the Android Tools and Libraries team.
I'm Romain Guy.
I'm Søren from the R8 team.
I'm Chris from the DevX Performance team.
I'm Shai. I run Android Platform Performance.
All right. Today we're going to talk about R8 and its implications for performance. So what is R8?
Yeah, so I guess that the people who have been following this podcast might have heard both Romain, Tor, and Shai mention R8 in a number of episodes. So yes, it's very great to have the opportunity to talk about R8. So thank you very much for having me. So first of all, I should probably clarify that we are doing two compilers. We are doing D8 and we are doing R8 on my team. And they're both responsible for taking your code the last mile from to be able to run on the Android device. So when app code is written in Java or written in Kotlin, then it's compiled by the Java compiler, the Kotlin compiler down to Java bytecode. But the Java bytecode does not run on the Android phone, so it has to go through another compiler, which is then D8 or R8. And D8 is the compiler that you use for your day-to-day development. That's a debug compiler that basically runs fast. It's incremental. You can do your edit, run debug step, run on device emulator very fast. Then R8 is the fully optimizing compiler that you want to run when you have to do your final release build. So R8 will apply all kinds of optimization to your code. The most important one, I guess, is removing completely dead code. When you build an app today, right, you use tons of libraries. And when you use tons of libraries, there's a lot of code you doesn't use. You use like one or two methods in some libraries, and then there's a lot of dead code. So what R8 does is that it is a full or whole program optimizing compiler, which means that it compiles the whole app in one go. So it has full knowledge of everything that's happening, which means that it can actually go and see statically at compile time what code will never be used at runtime. And that's kind of the primary optimization, that is removing completely dead code. And
Why do you have two compilers?
So why we have both R8 and D8?
Yeah.
Because there's two very different situations, right? You want to be able to develop your app, then you want to have a very quick, smooth cycle when you edit your code. You want to run it on device or emulator, and that has to take like a few seconds, which means there's no time to do any optimization. You just want to incrementally compile the single part you just changed, adapt your APK or whatever, and then deploy it to the phone. Whereas the release app is the one that you want to spend maybe 10, 20 minutes on optimizing. And that's why we have the second compiler, which basically compiles all code, whereas the debug compiler just compiles the bits that you've changed, and therefore it cannot do any like whole program analysis. There's just not time for it.
I see. So everyone uses D8 out of the box. Like it's difficult not to use D8.
Well,
right?
you basically can't do an Android app without D8. It is.
Yeah. So everyone who uses Studio and Gradle are using D8.
Yes.
Are they all using R8?
There's at least more than half of apps are using R8, maybe up to like 70%. Our current analysis says so. There's quite a few that use R8, but there's definitely more that should.
How do you know if you're using it or not?
How do you know? Well, you can go into your build.gradle file, build.gradle.kts file, and then you can check there is a setting on your release build whether you are using optimizing compiler or not. And it's
Minified enabled.
Yes, it's currently is Minified enabled. We are happy to say that we're also doing a new DSL, which is also already available under a flag in ADP 9, so that you have a more intuitive way of actually turning on optimization. It says optimization equal true, which is...
Why wouldn't people just do that?
Well, there's a number of reasons. So as I just mentioned, right, the R8 does whole program optimization, which means that it's statically analyzing the code, which means that it's trying at compile time to figure out what's happening at runtime. This is all good when you're using kind of normal code. You're just calling functions, calling methods, doing whatever. However, Java has reflection, which means that you can add runtime. You can conjure up strings, and then you can just look up classes or methods or fields using string names, which is something that typically at compile time you cannot see what the program is doing. Which means that if you're conjuring up a class name and then we can't see it at compile time, then, well, it's removed. It doesn't work at runtime, class not found exception, which is not what developers want. So that is when you have this kind of code, you can't just...
And you have the same problem with JNI, right? When you invoke Java or Kotlin code from JNI.
Even if you're not using reflection yourself, a library could be.
Absolutely, and it's usually libraries that do a lot of reflection, because there's a lot of libraries that implement like generic type of functionality, which of course is sometimes easy to do with reflection, right? You can just look up what's on your classes, and you can do something in your code based on that. So that's where the optimization breaks down, and we remove stuff that we shouldn't.
Yeah, and this is, so from the Android X side, ever since the early days when we were the support library, we've always had policies against using reflection and using JNI upcalls whenever you can avoid it, for this reason. I mean, there's also the other reason that they're also very slow, which is another great reason to avoid them. But we know that like we are going to get into murky territory with R8 if we ever use reflection, unless we're very careful, unless you work around it with keep rules.
Yes. And you mentioned the magic word keep rules, which is basically what you need when you have a program that uses reflection. Then you need to tell R8 that, well, there's something here that you can't see at compile time, but I am at runtime doing something on these classes, these methods, these fields. So you tell R8 as the developer through these keep rules that you cannot just remove these fields. You have to keep them, even though the static analysis of the program doesn't show that they're used.
And it's not just at the program level, right? When you're the author of a library, you can write keep rules specifically for your library, and then the toolchain will merge all of those so that you keep everything that you should keep in your program.
Yeah, these are called consumer rules, and those are merged into the whole program when that library is used.
So to your point earlier, Chris, like Android X can use reflection and JNI, it just needs to provide the right keep rules.
Yes. Yeah. So like a classic example that I always give is Work Manager. So Work Manager will instantiate workers based upon string names, especially when it's loading those up from say a database after the fact and trying to like check in with the system about those. Like those string names need to be consistent across builds and continue working. So what Work Manager does is it has a keep rule that says, hey, keep these properties of these classes that extend to this class. And it is tightly scoped to ensure that all that it's doing is preventing optimization of those specific worker classes.
Maybe you can say more, because I feel like you ran into something where these rules were overly broad. And then so you end up consuming someone's well-intended poor keep rules. And as a result, R8 couldn't do its job properly.
Yeah, so it really depends on the individual library that you're looking at. I did a lot of review over the Android X libraries, and there's very limited use of broad keep rules. I think the main cases that you'll see inside of Android X is things like JNI upcalls into known POJO structures to construct things. So you use a keep rule that says, hey, R8, don't optimize anything in this very limited specific package. Now, that's reasonable. It's not terrible. But what is pretty bad is when libraries just say, I have some sort of R8 problem. I'm just going to keep my entire library. And this is, unfortunately, as we've been talking with people trying to help apps improve their R8 configuration quality, we see a lot of people sharing their configuration.txt with us. We review it and we see, oh my goodness, this library is keeping everything. We look at these libraries on Maven.
And it has downstream effects, right? Because when you keep something, at least in my experience, there are other optimizations that R8 can do for performance that can't happen because you told it to keep everything.
Absolutely. So R8 will do, I mean, the main three things that like we talk about R8 doing is, as Søren mentioned originally, dropping dead code, tree shaking. It also will optimize, and like this is kind of critical because it'll say, hey, this method is always called with this parameter. Let me inline that parameter. Or this method is called all over the place, but it's tiny. Let me just inline it.
And I think it's worth emphasizing that some of the optimizations R8 can do, you cannot do yourself by hand, right? Because it works at the bytecode level. So there are things.
Is this where you just detect, for example, that there are no subclasses of this open method, therefore we don't have to make a virtual dispatch? Is that the kind of thing?
Yeah, that's one of them. It's also like if you have an interface, you only have one implementation, right? Usually you have an interface to be able to have multiple implementations. Sometimes you have a mark in your test, but when you actually build your app, you don't use that implementation, which means that R8 can see this interface only had one implementing class, and then it could just merge the interface down into the class, implementing class. And we can also do...
And that's where a keep rule would keep a class that suddenly made it no longer not implemented, and therefore the optimization can happen.
Exactly. So saying that, for instance, if you keep the interface, then you'll say, well, then you're telling R8 there might come other implementations along that we can't see statically. So that will kind of prevent that specific optimization.
So the impact of these optimizations is actually much larger than most developers realize. And this is maybe a really interesting side note. We said there are 2 compilers. I think that's a gross understatement of how many compilers are actually involved in the process.
So good. Yes, Android likes compilers.
Yeah, okay.
That's right. There's many, and one of the many other compilers that are involved in this process is the compiler that ultimately runs on the device and then takes the bytecode that was hopefully very thoroughly optimized through Søren's maximum power whole program optimizer, and then compiles that to actual instructions that the CPU that you have in your device.
Yeah, and I'm glad you bring that up, because to me that's key. One of the things I found with R8 is that the work it does paves the road for art, and I've seen, it can make a massive difference.
So we co-optimize those different compilers so that the compiler that you run on your computer as the app developer to build the code can not only optimize the code as much as possible, but leave all kinds of hints so that then the compiler that runs on the user's device can take it further.
Can you give an example of something that you would leave behind in the DEX code that helps the DEX code, I guess?
Yes, absolutely. So one example for that is a lot of app developers use include baseline profiles, startup profiles. So by doing that, and it's its own topic, and we could get into that another time. But by doing that, you basically say, hey, these methods are more important than others. All methods are important, but some are more important. These methods are hot. These methods happen during startup. They need to be fast. And so one thing that we can do is we can say, okay, if you have hot code and you have cold code, that is a hint to inlining. So inlining happens when you have code that calls other code, and you can just say, why don't you take the code that is being called and pull it up to the caller? Well, should you do that or not is sort of guesswork for the compiler, because the compiler doesn't get to run the code. It just compiles it from one form to another. But if you give it a profile, you say, hey, there's a hint. These methods are hot. These methods are not so hot. And then the compiler can say, well, I don't want to inline cold code into hot code, because then it becomes lukewarm code.
But to be fair, that isn't actually from R8 either, right? Like that came from a run. Are there examples of cases where there's stuff in the DEX code, in the, I guess, bytecode that R8 saw that thought like, hey, I'm going to inline this, but I'm going to leave a hint about what it is. I know that earlier we did resource shrinking. In AGP, and we would note which R constants actually corresponded to original resources, even though it was just a number in the end. That was a useful piece of information later in the pipeline. So I'm just wondering, are there cases of code optimizations happening at the R8 level that is code?
Yes. So, for instance, there are certain patterns in Java or Kotlin programming language that are very pretty syntax, nice to use, and we end up desugaring those patterns to something that the underlying Java language bytecode or what have you can actually work with. But we can desugar the beautiful code into functional code, and then in such a way that the compiler that then lowers that functional code to ugly, non-human readable code for the machine can then say, oh, I recognize this pattern. This is not just any other code. This is, we're appending two strings, something that happens very commonly in programs. I have just the right super specialized intrinsic for that pads the bytes the right way and allocates the memory in so and takes advantage of all kinds of properties that really that compiler can do. So when we develop and test these tools, we develop and test them not in isolation, but in cooperation. We have different teams that work on this compiler and that compiler. They meet regularly. We run complete benchmarks that test the whole thing end to end. And sometimes we go down to the individual instructions or performance counters for the CPU to see the effect.
Yeah, I think we had an episode with you and I remember talking specifically about this. So if you're interested in this, there's an episode on the compiler explorer and some related
I believe so.
Yes, we added a couple of years ago support for 2 compiler explorer, godbolt.org. You can run D8, you can run R8, and you can run Dex2out, which is the on-device compiler, and you can see everything.
So the only thing when you use something like Compiler Explorer, because R8 is a whole program optimizer, when you're not testing against a real application, you have to be extremely careful because sometimes R8 will see optimizations that make sense in that limited context, but would not happen in a larger application. So I found sometimes, for instance, I was forcing R8 to keep some things knowing that they would be kept in the real app so that I could see the actual optimization I would benefit from or not.
Is this something where, I mean, we talked about the startup profiles and so on. I'm wondering if there's more profile capture that would help R8. In the old days, you had these things, right, where you would like run a collection run with the compiler and then you would feed it back later for proper optimization, right? But I'm just wondering, is that something that you have or are working on?
So definitely R8 is well aware of baseline profiles and startup profiles. So basically what we do, as Shai already mentioned, right, when we know about profiles, we just make sure we don't pollute one type of code with the other type of code so that we can make sure that what you have in your startup code is not being polluted by non-startup code. What you have on your baseline profile, so the hot path, which is after startup, is not polluted by non-startup code. So that we have these kind of three categories. And there's definitely more opportunities for R8 to get more information from profiles. It's something that we've been working on, but this is kind of the stage we are at the moment. So
speaking of that, I'm going to ask a random question now. But, you know, every now and then when I analyze my APK, there's like 6 or 7 or 8 .dex files in there. And I'm on a hunt to find my code. What is the logic to what ends up in which? Is this something that R8 is involved with, or is this AJP? Or who decides what goes where?
So that is exactly one of the parts of both R8 and D8 that is laying out the final DEX file. So it is R8 that will do the final distribution into files. And so we have a rule that says that startup code goes into the first DEX file. If it fits, hopefully it does. Otherwise, it's probably your startup profile is too broad, but otherwise it will overflow into the next text file. And after that, we'll then distribute the rest. And the distribution is trying to keep code locality, which means that we'll collect all the classes in the same package in one text file, and so that all classes in some packages in the same text file, because code locality is actually pretty important because code within the same package will typically call other code in the same package, which means that if that is all together, then it's on the same memory pages, and that will kind of make going from one function to another way faster. And it's also that when you have then run dex to out, so the compiler that produces native code, it will, to most extent, it will keep the same locality as the dex file has, which means that the layout of the actual final, if you have machine code for your method, then they will have the same locality.
I wonder, I mean, this is probably just an APK analyzer usability thing, but like I'm always picking the wrong one. And I get excited because I expand it and I see my package.
Well,
it's the R class.
Because the tools are
right?
bad.
It's one of those things where like I'm finding all the Android X, all the libraries, and like it seems like my code is last. So I don't know if we could have like like an index or something, package to file name index as a text file at the top.
Well, you can click and shift select multiple dex files, and it'll load all of them all at the same time.
But I'm drilling in. I'm trying to get to, I want to decompile the code, and maybe I should just use Romain's tool instead, right? But
or Compiler Explorer.
So I mean, Studio will let you do that, right? If you click all the dex files, then you can find, and you are looking at the deobfuscated names, which is easier to do when you're using a bundle instead of an APK because it has the mapping file embedded inside of it. Then you can just find your package, click through, and you should be able to decompile it from there.
I usually use Backsmiley to just decompile everything into disassembly and just grab in it. That's kind of the fastest thing because you're always hunting the wrong place. That's for sure.
Just look at the ARM code.
Yeah, why not? And when you do, you see very interesting things. So
yes.
Søren was telling us, for instance, about how sometimes you have an interface in your program, and there could be different classes that implement this interface. Otherwise, you wouldn't write an interface. But actually, in your release build, in production, you only have one class that implements that interface. So if you write your code in Java or Kotlin and you say, oh, I have an ifoo, I don't know if it's a real foo or a foo for test. So I call ifoo.some method. And at runtime, this is called a virtual invoke, where you have to say, okay, this is an ifoo. Let's look up some tables, see what is the actual implementation, where does it come from, and chase a pointer. Finally, we can call the code. And so in your code, I hope you're writing tests. And as you're writing tests, maybe you extract an interface, you have a test double, you call that, and so on. But this magical whole program optimization that Søren tells us about can see, in your production APK, you don't ship the tests. I hope you don't ship the tests to the user. So real foo and ifoo can get merged. So there's no need for an interface anymore. And then the instructions lose one level of indirection. So there's one fewer pointer you have to look up and then go to a different memory address and load from that. And it turns out that really helps the silicon get things moving, because every time you load something from memory, you might stall. That might not be in the cache. You might need to go to the DRAM, and suddenly 100 cycles, you're just...
And these kind of optimizations can get very impressive. I wrote a blog post about something that we were working on for Compose, and basically we were building objects that it involved a lot of like bit manipulation. And so when you compile it, the regular way, you get a stream of like 200, 300 instructions, like a couple pages on your screen. And then you turn on R8 and it becomes loading one constant. Because there's enough inlining that has happened in R8, and then R8 is able to see more of the program and can compress everything down to just the one instruction that was needed.
And this is the part that I think it's important to make APK smaller and so on. But, at least on my phone, I have enough disk space. I have good Wi-Fi. I'm less motivated by the shrinking. Although I understand that the shrinking does offer, further performance benefits, but I'm most excited about making it run faster.
Well, and again, it does a lot of optimizations you cannot do yourself. Because there are some, sure, you can inline by hand, right? But there are things that you won't be able to do on your own, especially when it's in library code. So, and it's not every day that you're handed a tool that can give you double-digit % performance improvements kind of for free.
Yeah, I think that's a really important part about like taking these hey, we're optimizing things and like kind of making that into a concrete number. Now, I don't have a concrete number, but one of the things that I think is always impressive is when we reach out to partners and they tell us their stories about turning on baseline profiles in R8 at the same time, and you have lots of people reporting 30% performance improvement. And also one of the big things that was surprising to me is just how much it improves ANRs. And I mean, to some degree, that's kind of intuitive, right? Like the worst performing case of my app, when it actually ANRs, is probably going to be code that ANR? Oh, sure. So ANR, application not responding, is when your application's main thread isn't able to respond to messages for a period of 5 seconds. Now, that's a huge amount of time. A lot of times it happens in the background when some service is doing something. It could be any number of things that are happening wrong there, but one of the commonalities to a lot of it is just that you're hitting infrequently used code that hasn't been optimized. And by turning on R8, a lot of those ANRs get to be pushed down below that 5-second threshold, especially like these background ANRs, which are unfortunate for you crashing your application. Maybe they're not super visible to the user, but you definitely want to avoid them. It's awesome to see how much those ANR rates go down when people turn on R8.
And I would also add that R8, I think, is critical when you use Kotlin and Compose, because with Kotlin, the standard library becomes a library inside your application. So Søren, you mentioned that you're going to get rid of the code that gets unused, and obviously you're not going to use the whole standard library. So it's an easy way of
doesn't it also Kotlin adds
and then
lot?
Yeah, lambdas.
Oh, I was going to say something
lambdas.
different, but that too.
Oh.
Okay, I was going to say it inserts a million boundary checks. Anytime you jump between Java and Kotlin, it'll do some null checks because they don't know.
Oh, don't get me started on those.
But you do whole program analysis.
So from whole program analysis, of course, we know when there's a non-null value always flowing in, we can remove a null check. But we have actually done, for the latest version of AGP, we have gone even further. We have actually added an option to just take out the Kotlin null checks, either in a very the hard way, just remove them, or just replace them with one instruction that just will give an NPE, but without all the text, because these null checks have nice
the parameter names.
Yes, there's nice messages, so you can see which parameter was of your method was non-null, which is of course nice when you're debugging, but in a release app that should not really be interesting. You might need a null check, but you can get it almost for free, or you can just completely remove it because it's almost never needed, right?
And those checks are very frustrating because also the way they're implemented in Kotlin is pretty expensive.
Yeah, there are giant strings and string formatting and stuff, and
And not just the string formatting, it's like it's like those check and require calls, like the way they work, like the throwing of the exception is in line with the call side, so you page in a lot of code that doesn't need to be there.
Yeah, and that just calling a .get class on a reference, that's kind of very cheap.
It is remarkable how much code in apps is for handling errors.
That never happened.
Ideally never happen, or when they do, then that code is necessary.
Well, I said that never happened because some of those null checks, when you compile Kotlin
actually
code,
impossible.
Right, because
Correct.
the compiler assume that Java code might call into Kotlin, so it has to double check, even though you said this type is not nullable. So if you only use Kotlin, you know it cannot happen. Although there's a compiler bug.
So this is really one of the things that I love about these tools. So in my current role on performance, I just want everything to be fast. And when developers bring their fancy new tools and libraries and languages, I just think of all the ways that this will make the app slower. But I also worked on apps, and as an app developer, I just want the best tools, and I want to just type up pseudocode, and it becomes whatever logic.
And finding nulls for developers actually does save them time.
Mm-hmm.
That's
right?
true.
So like this was a useful productivity feature, just a bad performance feature, and that's where
So this is a great example where we can get the best of both worlds. So you can write a beautiful code, nice and clean, add your tests, do all your abstractions. And in your development environment, you get all the benefit of that, all the safety, all the testing, all the readability. And then when you're ready to ship, you press the button, go make a coffee, R8 is done, and you have all of that, all of those safety checks that are actually provably unnecessary go away. Those huge libraries with all the robust functionality that you are depending on, the functionality that you don't need goes away. And you ship something optimized to the user when you're ready to ship.
Yeah, no, Søren, you said 20 to 30 minutes. That's more than one coffee, I would say.
Yeah, well, that it depends on what coffee you drink.
Yeah.
So
I think
maybe
we
a
talked
croissant.
about this is all good, right? Like, let's talk. There are some downsides, right? So we mentioned one is that your app could
Don't
crash.
tell that to people.
No, because I believe you have been working on some mitigations, right? So I want to talk about the the potential downside. One is your app crashes. Another one is when there's a big discrepancy between what you're debugging and testing in your Android Studio and the crash report you get, right, where the line numbers don't match and so on. So, can we talk a bit about like what these things are and what you're doing about them?
Yeah. So first of all, of course, when you're doing optimization, and you're also one of the optimizations we do for making things smaller is we rename things to ABC, and we merge classes. So suddenly you have one class that represents 10 classes. So when you get a crash and you get a stack trace, then you just get ABC on your call stack, which is not very useful. The good thing is that R8 outputs a mapping file which can actually be used to map that thing back to where you came from. And one of the things we've added recently is that inside those stack traces, the stackers with the very confusing names, we have embedded the hash of the concrete mapping file that you need to uncover the stack trace. Because as a developer, it's very hard to keep track of all these things. But then we have also added into Studio so that when you are testing this release app in Studio, then you can just click on a button in the logcat viewer, and then it will go fetch the correct mapping file from your build, and it will recover your stack trace. You don't have to do manual commands. You can just use it in the IDE.
Yeah. So stepping back a little bit, like we've had a lot of this stuff kind of working by default in production. If you're using Crashlytics and you're uploading a bundle file and it contains a mapping file, all of that would work kind of flawlessly. And now the big change is I think it's like requires AGP 8.12 or something like that. But once you have that, now that can work in Studio too. And we're trying to make developing on an R8 application feel just as easy as developing a release D8 build.
So if I'm switching to release binary locally and I hit run and then it crashes and I look at logcat, if I click on something there, are we like automatically de-obfuscating it?
Yes.
In place in
Yes.
log? Okay, even better.
Yeah, I think we de-obfuscate it in place, and then we have a button to see the original stack trace. Is that how it works?
Yes,
Or
I think,
maybe-
you could still get the Mangle one
Okay.
if you just maybe you want to check whether it's the same as you got from the wild. Yeah. So that's a huge improvement.
Are there cases where I can turn on optimizations that are unsafe?
Yeah, so actually this is maybe a good step into the fact that we have done this massive documentation overhaul for R8 over the past year. We have, for a long time, we had a lot of little details about how R8 works and integrates with AGP, but really didn't describe its user interface in our documentation. And now we have a page on that. We have a page on documentation for additional optimizations that you can force on that may not be safe if they're misused, but there are a number of those. You could force assume value. You can use additional keep rules that kind of serve as the opposite. Instead of don't optimize this, no, I can tell you ahead of time it's safe to optimize this, or you can force this optimization. So you could assume values to say that this field or this constant, or that this variable is always constant. Assume that my debug flag is always false. You can do things like that. There are also top-level flags also that we document in the global flag docs that talk about that too. But just in general, we know that for a long time, it has been very painful to learn how do these keep rules work, what is the syntax of them, is this an appropriate one? And we have documentation talking through what are good patterns, what are bad patterns, why should you be using these, and lots of examples.
That's fantastic news, because I have spent a lot of time reading through the source code of R8 to understand some of the rules. And
never again, hopefully.
Well, I mean, it's interesting, but
Oh, well, yeah, I'm never again for the average person. I'm sure you'll keep looking.
Yeah. So first of all, R8 has a lot of optimization, and there's no way of controlling which one run and which one does not run, because that will just be way too complicated.
And you're only picking the safe ones. I'm assuming.
Yeah, of course we are. And then what has been a problem, especially in the past, is that there's this nice knob that says "Don't optimize," which turns off all optimizations, because then you can probably fix some crashes that you had, and then everybody forgets about it. And that is a real bad smell, and you should never do that. We have done various things in both AGP and lint to make sure that we call out when people do this. Maybe they don't know, they just forgot, or it came from somewhere they are not aware of. So we help them with that.
This is something.
How? So you said AGP, so is it like a build time warning or something?
Yeah, so for a long time, we had two different configuration files that were considered default ProGuard flag, or the default flags that would be passed in, that would be things like keeping things that we know that the framework will call into that you might not need. I think that includes the default like enum keep rules. But one of the things that we recognized as we were starting to play with, like what are the defaults? What does it look like when I get things out of the box from Android Studio? Is we just noticed, this thing that we've always had as a configuration flag, which a lot of people have in their build files, is get default ProGuard file, and then you pass in a string, and that's either Android optimized or Android. What is it? Android.
I can give the history on that, right?
Yeah.
Because this actually comes back from the Eclipse days,
yeah,
right? And we had one of those things where we go like, "Oops, that flag is bad," but we had already copied those files into your project, so we thought you can solve every problem with one level of indirection. So we thought, like, if we just let you point to a file, but we'll maintain the file for you. That's why we did that.
Okay, yes.
But obviously, that file we never looked at again.
Yeah, and at the time, I think it made sense that turning on optimization was a potentially dangerous thing because it wasn't super well tested. And now, there have been, 6 years of R8. Like, it is very well tested what optimization does and can do. And so it does not make sense to support that as like kind of a default configuration out of the box. So what we did is we added a lint rule to warn you, hey, by the way, you're using a flag that is so I mean, if you're declaring -don't optimize in your keep rule file, that's pretty obvious that it's doing something rather dangerous. But what isn't obvious is the AGP API that is give me the default ProGuard rules, right? So what we did is we added lint to say, hey, don't use this one, use this other one. It doesn't include don't optimize. And then in AGP 9, we just broke it. We just said, you cannot do this. If you want don't optimize, you have to tell it to me. Don't be shy about it. Put it in your keep rule file yourself and admit to your failure. But I think there are a lot of these kind of usability problems that we've been looking at recently, especially in AGP configuration of R8, because there are a lot of things that you can kind of control in ways that are not obvious. So one of those is the default ProGuard rules themselves. So something that I found out that was very surprising is if you do specify a custom rule file, a custom keep rule file, you don't get the default rules. You have to add them manually. Okay, fine. But if you delete that file, if you don't have a rule declaration file, then you do get them by default. We're working on improving that.
It makes perfect sense to me.
we're working on
to anyone who has read all the source code for the plugins, it makes
yes, when you know how it works, I'm not
exactly
surprised.
how it's implemented.
Yeah. So we're working on improving these and kind of overhauling the experience.
That's
for
good.
that.
Yeah, and having more documentation is great because some of those keep rules can be a bit mysterious at times, and I know they were shared with other tools, and the documentation was not great.
Yes.
Yeah, and also when you look at the default keep rules, right, there is a good reason for them, because even though we said reflection is not a good thing, then initially Android was built on reflection, right? The whole view UI model is based on reflection all the way through, right?
Yeah.
So
well, I would say Java in general, it's a very popular.
Yeah,
thing
it
to
is
do, right?
like kind of a first.
But I think there's been a shift in the community as well. We've seen, especially now with Kotlin, like a lot more code generation, like especially when it comes to dependency injection. So I assume it's probably easier nowadays to.
Well, I'm assuming you have I know we have special handling for views.xml, right? You know, like any layout file, it's all reflection. That's how it works.
Yes,
And
but when you get into the guts of a library, it's much harder. And I think this is a great segue to talk about JSON. So JSON is a popular reflection library, a popular JSON inflation library from Google, but it is kind of fundamentally built on reflection. It is very, very easy to build yourself a foot gun in JSON, even if you are trying to use the annotations that they provide that do have keep rules associated with them. And like that talk of code generation is a great segue into the fact that there's just way better alternatives now. We have Kotlin X serialization, we have Moshi code gen. Both of them are totally fine and great alternatives. There's even like guidance on the Moshi code gen page, I think, about migrating from JSON. But both of those work flawlessly with R8 out of the box in comparison to JSON, which will sometimes work. Now, I've seen like legacy JSON code, I think, is a lot of what we talk to developers about in terms of why they have wider keep rules. And it's very common to say, well, I don't want to, have to migrate this around. So like, let me put a package-wide keep rule on them. And if you're very diligent about saying JSON will only inflate things from this particular package and it only understands that, then that could be fine.
And you put the data classes, only the data classes in that package.
Yes, but you have to be very careful about it. And CodeGen is just safe by default.
Well,
and it's probably...
And also, even if you're diligent about it, I mean, over time, let's say you have, a new engineer joining your team, they may not be aware, because that information is somewhere else entirely. It's in this file, like mysterious file somewhere in your project, and it's very easy to like not know that it's there.
Can you write a unit test that verifies shrinking behavior? Like if I wanted to assert that in my release binary, I expect to see this and never want to see that. Is that something that a developer can do today?
Yes, I think we're not talking about why are you keeping so much as we're talking about...
Are you talking about check
it's the guard against
then?
romance scenario. Like I have now intentionally segmented my code over here, and I have the keep rules just so, and I want to protect myself against someone doing something dumb later. Yeah. Right? Is there something I could express that?
So that there's a keep rule. There's also like what Shai mentioned is called check discard, which basically says that what matches this rule should never be in the output. So there's a way of ensuring that something gets removed. It can be used for various purposes. Of course, make sure that your test code doesn't get into the app. You can also make sure that if you're like building different flavors, like a dog food version or beta version, that you don't want features to leak. So you can also use that to make sure that your build actually is configured correctly, so that it will remove what you expect it to remove. So this is one way of making sure that your
that's super interesting. Because I've often in the past used like if false and relying on the Java compiler removing bytecode that is like
but even when
knowable.
You did that, you didn't really know that it was gone, so you didn't necessarily have a test that was looking at the
exactly.
bytecode.
This was just like knowledge,
believe,
quote unquote.
You believed.
I verified once or twice, and then I was like, okay.
And then you got bored.
And as the tools update out from underneath you, you just assume that that's true.
Yeah. It's normally a way better way to keep code around because it's still being compiled. So you can if you comment it out, things happen, right? But this sounds like a way better thing to do to actually mark it as deletable.
So this is one of those cases where performance and security meet. Oftentimes they work against each other, but in this case they come hand in hand. So Søren gave the example of I want to make sure this feature doesn't ship because it's not ready yet, or I want to make this sure that this code doesn't ship yet because it's a secret new project that we haven't announced yet. And it's in development in our code base, but we rely on R8 or other tools to strip it before it goes to the user because we know how much bloggers like to...
Nothing has ever been leaked by looking at feature flags inside an API.
Is this just an enforcement flag, or is it a way to say, hey R8, slice this out?
It is a way to check whether it's been removed, and the build will fail if it's still there.
Okay.
So it's not forcing it out. We don't have a way to kind of force things out.
Okay, well, that's your feature request for the episode, the first one.
Well, so remember that the default behavior of R8 is force anything out, right? Like that is the default of shrinking. And I mean, as long as you're not disabling shrinking, you'll get that by default for every single class that isn't referenced.
Yeah, this is why R8 takes time to run, because we don't tell you what to remove. Rather, we discover what are all the things that need to be kept. Yeah. So we start with the roots, the entry points to the program, the code that we know is live by virtue of its definition, and we walk a graph of sorts and we color it. And this is why I could write 2 lines of code and run R8, and it would take the same amount of time to re-optimize the program as going from scratch, because it is a whole program optimizer, which is why you don't want this in your edit, build, run cycles, but you do want it when you're ready to ship.
Are there ways to make it incremental?
No, not at the moment. No.
Okay.
So yeah, it's
That's
basically
like a hard problem.
Yeah, it is a hard problem because when you change one thing, it just have a ripple effect through the whole compilation pipeline. So it's a hard problem.
It's just like if there's a graph, I'm assuming there are subgraphs, and I'm assuming that you could. But anyway, like I'm sure that's another request. Speaking of libraries, one of the things I'm excited about is the what is it called? The running R8 on just libraries. Was it partial?
I was going to ask about that. I wasn't sure if we could.
I'm trying to remember the name.
Yeah, so gradual R8 is kind of what we describe it as, but the API is package scope, and that's what the documentation calls it as well. So that's a way for you to say, you know what, I have some dangerous things, some dangerous reflection somewhere in my application. Let me just get the default configuration for something that is a subset of all of those packages. Let me only optimize a package at a time and kind of add a package at a time. Now, keep rules today will allow you to opt out individual packages by saying keep, my package .. Those are pretty dangerous. This one, because if you specify something too wide, you can turn off optimization. And we think of those as things that you only do temporarily. This is kind of giving you the opposite tool to allow you to work incrementally and add more to your optimization as you are trying to adopt R8. So instead of doing a whole program analysis and optimization, it is just doing that optimization over a...
Is there a default list, for instance, all the Android X libraries, because those have been tested?
That's what I was going to say, is that for baseline profiles, initially we only did it for Compose. This was one of the ways we could ship Compose, because we wanted to pre-bake startup or baseline profiles into Compose because we needed to run faster, and we knew that part we can mark hot, even if there's also important application code. Initially we started with just known libraries. And it feels like you've done all this work on the Android X libraries to make sure they are safe as well. And so I heard that you've done something where even if people aren't using R8 in general, we can at least, do it on that part. Is that the same thing you're talking about?
Yeah, so that's what I'm talking about. But at the end of the day, the API that we ended up with was one where you still specify a list of libraries. And in the documentation, we say, at the very beginning, put Android X, put Kotlin in there, because those libraries are safe, and those are some of the most important ones to optimize.
Not only safe, but something like Compose, it really helps to run on R8. It really does, because every component that uses a Lambda, we at least want to merge all those Lambdas. There's a lot of things.
Not enabling R8, at least on Compose, or especially, I've seen a couple of configuration.txt's come by where people will disable it for all of Compose or all of Android X because they're probably working around some weird little bug. Please descope that. Please pull that down to the absolute tiniest version that you can, because if you say, I don't want an optimized toolkit, I don't know what kind of user experience you want.
Yeah. And talking about Compose, this is one of the libraries we have been spent quite a lot of time on the R8 team to actually focus on, because there's as Romain said, there's a lot of Kotlin magic in there with lambdas and nice use of Kotlin features, but it also kind of generates a lot of code that is sometimes slowish. But we have really worked our way through that code and done value propagation in all kind of sorts, including handling bit sets and stuff like that, to make sure that we can actually trim that code and make it fast. So I think that when we had the last work on that part, it removed the number of instructions in the Compose code by about
So that
25%.
one is interesting. Can you elaborate a little bit more on that bit set? Because that's something that Compose developers will never see, but it is fundamental to Compose and a very important optimization.
Yes. Yeah. So that is when you have a composable, it usually has like huge amount of things you can set. So if you have a text field, right, it has a color, it has style, it has like 20 plus of various kinds. And then there's the way the Compose layout engine does is that it passes bit fields around to kind of check the state of what has changed and what has not changed. And when you do the right handling of these bit fields, then you can suddenly trim out a lot of code that is not needed at the runtime. So there's a huge benefit there.
Does R8 do the same because Kotlin does the same for optional parameters, where you end up with a bit field, and the problem is that it gives you an extra function call, lots of branches.
Yeah, we do the exact same for Kotlin and default arguments. So if, for instance, also if you can see that this bit in the default argument field is never set because we kind of find all the calls and we say that this bit is never set means that this argument is never passed. So we can even remove the argument completely.
Another example of this is dependency injection. So if you're a well-behaved app developer, you write your tests and you create these interactions, dependency injection, to get your dependencies from and swap them out in testing, or maybe not even in testing in different environments. That's an interaction. I need to go here and I need to get the thing that I actually need and then operate on it. And if R8 can prove that getting the thing will always, the outcome will always be the same, it will always have the same result, then we can remove that interaction, peel away the abstraction.
I'm sure we've talked about this in a previous episode about performance, but I found that it's always beneficial when you try to write code that's clear to both a human being and the compiler. Well, it's easier to read and maintain the code, but also you get a lot more optimizations out of everything because the compilers can reason about your code.
You can also do, as a team, it really liberates you to do things where in the past you might be worried about, what is the performance impact on this, especially for users that don't benefit from a feature. And now you don't have to worry about that. You have to worry about that less or not at all. And Compose is a great example for a team that went from adopting R8 to fully buying into R8 to the extent that they develop things, they write their code in ways that they could not write their code and still assume good performance because they tie it in with R8. But it's not the only team, of course.
Yeah, R8 doesn't only emit DEX, right? And the reason I'm asking is that Android Studio, we're increasingly using more and more Compose. But we don't spit out R8. We run on JVM, right? Could we adopt R8?
Yes. So there's no. So as I said in the beginning, right? D8 and R8 is for taking your code the last mile to DEX, but it is actually so that R8 can also go class file to class file. So you can optimize any Java bytecode with R8. Actually, when you get R8 on as part of your build with ADP, R8 has been optimized by itself. So if you actually are so unfortunate to get a crash in ADP in an R8 compile, you can actually see that the R8 part of the stack trace is very mangled. We kind of eat our own dog food.
Engineers always like to play.
And that's still whole program analysis. It's not just class file to class file.
So no.
Whole program analysis.
It's the full optimization pipeline. Just there's a few things that we can do with DEX because we know DEX has slightly different semantics. For instance, there are some of the limitations that the JVM have proposed on, especially on some constructor patterns that the art runtime does not, which we can take advantage of, so we can do even more on a DEX backend. But the class file backend has almost all the optimizations and the DEX.
Extra excited because we have so much Compose code now, and every time I write it, I feel bad about all the lambdas and properties and all this stuff.
But be careful with Compose for desktop because in my experience, you can optimize Compose for desktop, but it's missing a lot of rules out of the box, and the missing ones tend to change over versions of Compose desktop. So, you'll run into the problem that we are describing at the beginning.
And I'll get to debug some of the debugging tools. So let's talk about that. Okay, so let's say, what are we doing around debugging crashes when the app has been optimized with R8?
So, the first thing that Søren mentioned earlier and that we talked a little bit about was the demangling of those of those stack traces. But also one of the big things is that we just have a lot more documentation now of what is the problem pattern that you see and how do you write a keep rule to protect yourself against that because you were being naughty and using reflection.
But when you run into one of those, the exception you get at runtime is like, your reflection call will fail, or it will try to call a method that doesn't exist. So that is not obfuscated.
There was a proposal, right, that you would leave in a little bit of extra, and give a more usable trail that something had been deleted. So instead of, no such method found exception.
So what we have been or are working on at the moment is actually to instrument the code so that you can, if you have something that uses reflection, then at every call site that has reflection, we'll actually instrument the code to capture what reflection happened at runtime. Which means that if you have an app that has been instrumented that way, then it will just track every single reflective call. You'll get all the various arguments that were passed to the reflective calls, and then you can run all your tests, given that you have a very good test coverage. And if you have a crash and you don't have test coverage for us, then you can start by making a new test that actually can reproduce the crash. And then you can run in the instrumented version, and then you can then take these, the kind of all the reflection that happened, and then you can compare it against your keep rules and make sure that then you can find what's missing.
So this is like a debug mode of R8. This is not in production. We will do something to make crashes
Correct.
more.
Yeah, this is bringing your release-only crashes into your debug mode so that you don't have to do a full R8 release, so that you can find them also in tests.
Okay.
Yeah, and you can have your CI server
still
on
coming.
these.
This is
You need a reflection profile.
Yeah, but it's an interesting problem because there's also reflection in there that is actually supposed to be there, and sometimes even supposed to fail at runtime because you can use reflection for feature checks. So it's not just an error that a reflective call is not finding what it's looking for. It might be the intent. So yeah, there's interesting problems in the area.
And then you've been doing something about annotations, right? Like it used to be, we had a keep annotation a long time ago, which was sort of frowned upon a little bit. It was very easy, but the problem was that it was sitting with the code that was being deleted, and that's not really the problem. You want to sort of keep track of the usage side instead, right?
Well, so the keep annotation today has a number of problems. Basically, what the keep annotation does is it does something that you can do in libraries today, where you say, I have an annotation, and then you reference that annotation from keep rules that are distributed in the consumer rules of that library that say, hey, when this is applied to a class, do this. When this is applied to a field or method, do this. Unfortunately, the way that works today is that it is, when applied to a class, completely unconditional and will keep every property of that class. When it is applied to a field or method, it will keep those if the outer class is kept, and it will prevent them from being renamed. But there's not a lot of flexibility there, and exactly as Tor said, that is with the receiver of the reflection, not with the reflection.
So if that class becomes unused, you still wouldn't know,
yes,
right?
You wouldn't know.
Or it's going to go like, we're supposed to keep it, even though it's no longer needed.
So the big thing that we've been working on is to try and overhaul like kind of this entire idea of what if we could move things out of keep rules into the code, but and exactly to your point, move them to the reflection call sites rather than the receiver call sites. And this has a number of different advantages. So when you put this on the reflection call site, then you're able to understand that this is coming from this function call into another one, which allows you to write a conditional keep rule. Conditional keep rules are where when you put a -if at the beginning and you state if this class or method is present, then keep these other things, which allows you to say, have an optional portion of your library reflect into something that doesn't force that thing to always be kept, even if no one's using that optional section of your library. So what we're doing is we came up with a keep annotation that allows you to specify a bunch of different properties of that receiver call, and then built a lint rule to automatically generate that functionally a keep rule, but in annotation form for any reflection call sites. And so right now we're actively testing this out.
What I really like about it is it's not actually a keep annotation. It's a uses reflection annotation.
Yes.
So it isn't saying this is going to keep. It's saying, hey, this is reflecting to this other thing.
Yes.
That has potential other uses.
Yeah, it does. I mean, so
if you just find usages in the IDE, theoretically, we should now also flag the reflective usages, right? By just looking for these annotations as one example, right? So it just, I love that this is what annotations are supposed to be, metadata.
Yes. So like, the primary APIs here are uses reflection to construct, uses reflection to access field method, that kind of thing. And they allow you to find the common patterns where you reflect into something and you refer to it. And the great thing is, I don't have to figure out the keep annotation syntax every time that I want to write one of these things. Because, the IDE will do some decent job of giving me red squiggles when I get it completely wrong. But it is much better to have something where I can just pass in class references when I have access to them.
And it lives with the code.
And it lives
so
with
when
the
you
code.
move it around, the annotation moves. So it is better all around.
You can refactor it, and it stays where it needs to be.
Right. Now, can we have the same thing for JNI? Or I can put that annotation in the C++ code?
I mean, so actually you could, so this is one of the things that we talked about when naming this annotation. You can absolutely use this for JNI if you know the Java entry point that calls into the JNI that has an up call. So
right, but I would like the annotation to be
in the native code?
In the native code where I'm using the...
Yeah. We would have to teach R8 about it.
Well, it's basically the same thing, right? You just have to handle it on the C side. So you have to have this the C++ compiler generate, have these annotations or metadata on the C code, and then spit out R8
When is
rules.
R8 going to start compiling C code?
when you cross-compile it.
Yeah.
Feature request.
Yeah. So we actually had a request of outputting information about what native code reference was left. So what system.load libraries calls was left in the code, and what native methods was left, so that in principle you could go and mock with the SO file afterwards.
So bringing this back from things that we're going to do or thinking about, like that actually brings us right over to optimized resource shrinking, which I think is one of the coolest things that R8 has done recently. Do you want to talk about that, Søren?
Yeah, sure. So optimized resource shrinking is basically taking resources, of course, is a huge part of an app. So and they're usually some of the artifacts that are actually the biggest. You have images.
It's way bigger than code, right? Like the launcher icon.
Yeah. And sometimes people forget to do it in the right resolution, so they are way bigger than they should be. That aside, we used to have a resource shrinking be something that happened after R8. So that meant that you had the AAPT tool generate keep rules for everything that was used in your view model and your R classes, and then afterwards we will then run over the code and remove that. Now,
what if you use reflection to access the resources?
Yeah, so then you need a keep rule.
We actually had that. We actually had attributes in XML.
There's a keep rule in XML, so they can say that this is used by reflection. If you do look up
about a third of the reflection in Android X libraries is exactly for that, referencing something that is in some sort of manifest or keep rule file, and inflating that dynamic.
Yeah, but going back to optimized resource shrinking, so what that basically means is that instead of the resource shrinking and the code shrinking being two different things, then they are one thing now. So that basically means that R8 receives the code and it receives all the resources. So in principle, all your resource XML files, which means that they can then do its walking and finding live code across the two things. So it's basically, it starts from the manifest, which kind of have all the rules, all the entry points into the program, and then it goes from there. It works through the code. They find out what views are inflated, what's found in the resources, and then it kind of traverses code to resources to code, and instead of having like those two be split, which can actually make quite a bit of savings, because there's just a lot of things that, especially when you take libraries, they have like activities for all kind of fancy stuff that you don't use, and in the old world they would not have.
Not even just that, but you routinely see online when people look at the content of APKs, they find files that have been left that were never meant to even be a resource, and some of those can be pretty big.
So I have a horror story for you. So Tor here is wearing this beautiful smartwatch on his left hand.
It's a Pixel 3.
That's right, and it has a gorgeous circular display. And a few years ago, I did some work with the team that ships the software on these devices, and they needed me to help them understand what are the different things that are kept in memory to keep this device small, keep the battery lasting all day, and so on. And one of my first discovery is in the memory on this device, I found several copies of a phone-sized wallpaper image.
Probably taken by Romain, I'm guessing.
It's possible. It could have been. A lot of those photographs are sourced from Romain's growing camera roll of beautiful shots. Yes, so it was sitting there on the watch, and it was there because the watch was using some default assets from the Android framework. And those assets had some kind of default wallpaper because you would need something.
And the watches did not exist when we wrote that code?
That's true. Many things. So Android now ships on so many devices. And even if you just constrain to a single form factor where you say, okay, just phones, there's no such thing as just phones because there is so much variation in terms of capabilities, which is why we also use R8 a lot, not just in apps, but also in the platform itself. So one example for that is a lot of times we will develop new features in the platform for the introduction of some new hardware capability. So these days, if you buy an expensive phone, it probably comes with some satellite connectivity capabilities. So if you're in an emergency and there's no other connection, you can still call for help and you can send your location, and emergency services hopefully will find you. And so there's a lot of code to run that modem and make it work, and also present you with the UI for how to find the satellite connection and what message to compose and what have you. And that code is completely dead and unnecessary on devices that just don't have the hardware to send the satellite signal. So we don't ship that code. There's a lot of checks in the Android platform build that check for what is the target device capability. You as a handset maker, not an app developer, are making a handset, and it has certain things and doesn't have other capabilities. What code is conditional on those features being available? Another example is there's features that are built just for VR. There's features that are built just for television displays. And there's no reason to ship those features to a watch or to an automotive head unit or what have you.
So is R8 capable of doing shrinking based on Android feature flags?
Yes, but you have to pay attention to how you generate the code for the feature flags. So we had done a lot of work on this, and maybe this is important for anyone listening who's working on a system for build time feature flagging or build time build flavor targeting, where we made sure that at the time that R8 runs, in the program that R8 inspects, it has all the information it needs for your release build to make a simple determination for, is this flag true or false in production.
So
Like
does
static,
it
like
use
it's not a runtime thing?
Does it use the assumed value that Chris mentioned earlier?
It ultimately bottoms out an assumed value.
Okay.
And importantly, you are going to want to have some builds of your software that do not assume the value and actually give you a runtime toggle. So being on the Android platform team, I carry around a phone that has the latest and greatest features. And many of those features are behind a flag. And on my phone, they're enabled. And if my phone starts crashing or is super warm, I can disable them. And so the code for those features is available, and the toggle is at runtime because
The toggle
that is
says turn off crashes.
Yeah, I turn off the crashes right away as soon as I get the phone out of the box. I don't know why.
That's a feature we should put in every phone. No, stop crashing.
I feel like we could talk all day. What have we not asked you about?
I think we'd like to talk about just maybe the primary few things that the average app developer should be thinking about when they interact with R8, where they think about optimization. So the first thing that I would say is turn on R8. If you need to, you can use the package scope in order to limit it to a subset of your application, but slowly march down that list of package-wide keep rules or packages that you're not including in that package scope and add them, because every single one of those big packages that you optimize, it'll reduce your A&R rate, it'll make your startups faster, and all of those have like actual measurable business impact.
Yeah, and I really want to stress out again, because I don't think we can stress it out enough, but yes, do turn on R8. Like the gains are so massive, and having this kind of gains like with manual optimization would take years of efforts. Like at least take
And
that
again,
win.
we should just turn it on for people, but we don't necessarily want people to have
Sure,
crashes,
that's
and that's why
fine,
we've been
but-
holding back, but
Yeah.
really we want...
What I'm getting at is that, it might be a bit of work, but it's nothing compared to what you get.
Yeah, and also there's like historically we had different modes of R8. So there was a compat mode because we didn't want to turn on all the optimization we had to begin with, because that was, I guess, the developers not ready for them. So we had a compat mode, and it's very easy to forget to turn that on, so you get all the optimization. So there's a make sure you use R8, make sure you're not using compat mode, make sure you're not using the wrong program configuration file from AGP, so that you get the full optimization. I guess that's the kind of steps you have to take.
Yeah, and all of those things are listed out at d.android.com/R8.
So I can give your listeners something maybe more substantial to think about in terms of what does this mean to get these performance uplifts? What does this actually mean for me as a user? So we've done a lot of work with certain app developers, top app developers on R8 adoption and getting the most out of R8. And in our studies, generally speaking, one of the things we do is we compare your app's performance in critical user journeys like startup or other important features in the app. We see how long does it take you to get into something. And we compare the whole thing before, sort of a before and after shot. And because we have data from different devices, we can also cast that comparison not in terms of you got a software upgrade as a user, but you got a hardware upgrade as a user. So typically when we work with a big app developer and they go from 0 to hero on R8 adoption, we see the kind of performance implication that is as if their user updated to a new device that is 4 years newer.
4?
Yes,
Wow.
between over 3, sometimes 4, 3.5, I would say. And we can draw those comparisons because we know how long it takes your app to launch on this 2026 device. And we know how long it takes on this 2022 device. And we can say your old software on the 2022 device your new software on the old 2022 device performs just like your old software on the 2026 device. It's like you've given your users a new phone or tablet or whatever device they're using for free.
And that kind of stat we've seen repeatedly.
Yes, consistent 3-4 year uplift in performance on the same series of device.
I mean, it's a pretty compelling reason to go try it now.
Søren, that's a lot of free phones you've given away.
So generous.
Yeah, that sounds good.
Maybe that's actually what's going on. Søren actually giving new phones to people.
Yes.
I suppose we buried the lead. Maybe we should have opened with R8 is a tool that makes your phone 4 years younger. Here's how it works.
Yeah, facelift for phones.
That's right.
All right. Well, thank you so much.
Thank you.
Thank
you so much.